Calculus Kids, this is Dr. Callahan with Week 11 Thursday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions. All right, well, let's just go ahead and jump right into it. So today we're going to actually start with your volume section. This is going to be our last topic for the semester before you guys take your AP exam. So go over to week 11 Thursday and take a look at the guided notes. You guys actually have several pages here. Here I have the diagrams that shows you how to go about finding the volume from a philosophical standpoint, and visually you can see how you can start off with a rectangular piece, and then as it evolves, how it creates a 3D shape of the volume. Like for example, in this case, it is a cylinder. So make sure you guys read these pieces. Then I have my notes right here that I've drawn for you guys, so that way you don't have to draw the notes in class. Today, this are going to be our guided notes. We're going to go over the visual parts of it beforehand, steps to find the volume using the disk method, and then the 3 examples. And then I have some additional examples here for you guys to take a look at as well. All right, so with that said, I'm going to have you guys go ahead and get started at the very beginning of this. So the first thing that you guys are going to do is we are going to start off with a quizzes, which is going to kind of test you guys on your ability to find the area of underneath a curve. And so we are going to go over to this page. All right, so you are going to have 11 questions, and I'm going to go ahead and assign this to you guys so that way you have time to go ahead and work on it. So your job is to make sure you guys go to joinmyquiz.com, answer the code 15669394, and you can go ahead and start answering these 11 questions. Okay, so everybody make sure you guys are seeing that. And yes, you have. So now I want to go back to the actual PowerPoint here. All right, so then let's go ahead and get started with today's stuff. So I'm going to have you guys get started right here on this page on your guided notes. And so we're going to go ahead and take a look, recalling the area of a curve if it was equal to y equals the square root of x. And it's between 0 to 4. So here's 0. And I'm assuming if this right here is 4, then here is 1, 2, 3. If you're going to find the volume, and this is actually the disk method, so we're going to go about trying to create a disk. So looking at this part right here, essentially what you're going to be doing is you are going to have a rectangle like so. This width of this rectangle is going to be dx. The height is going to be f of x, okay? And if you can imagine this disk rotating and evolving around, it's going to create a circular disk, okay? Now, if you don't just have one disk here, but let's say you have a multitude of disks circulating around the shape, and you add all of those disks together, then it's going to create this volume, because essentially you're just stacking a disk on top of a disk, okay? And then just keep in mind, if you're creating a disk, this piece right here is the radius, because you have the diameter, which will be the entire length of the disk. So half of that, which is the height of this rectangle, is going to be the radius. And so as you're looking at this, the area is going to be equal to integration from a to b. F of x that is going to be the height of the rectangle times dx, and this is going to be the width of the rectangle. So if I were to plug this in, a to b, what is your height for this? Well, if you think about it, f of x is a height, and what is f of x? Y. Your y is square root of x times the width, and what is the width? Dx. Okay, so then if I'm going to go ahead and evolve this, take a look at this diagram. So here is where your rectangle lies, okay? We've established that this is dx, which is your width. This is your radius, which is also going to be your height, which is y, or f of x. Now, if this continues on rotating, take a look. You have a stack of disks added together, and you're going to have them from A to B, because with each revolving rectangle, you create a disk. This is your radius of the disk, and you just add them on top of each other. So then your volume is going to be, if you think about it, okay, it is going to be the area of this circle right here. And how do you go about finding the area of the circle? Well, if I just take one circle here, you know that this part right here is your radius, which is another way of writing r of x, capital R of x. So for you to find the area of this circle, it is just pi r squared, which if I were to rewrite this, pi times capital R of x squared. So then translating this into your volume, you have the area of this circle times the width. So the area is pi capital R of x squared times dx. And so if it is a top-bottom vertical radius, and in which case it matches this one here because it is a top-bottom, your volume formula is going to be as so. And it says the axis of revolution is going to be a horizontal line, okay? Now, on the other hand, if it's a right-left horizontal radius, meaning this way, okay, it's going to be pi times the integral r of y squared times dy. And the axis of revolution is a vertical line. So it's kind of an interesting concept to grasp, but for now, for the time being, just keep that in mind. All right, next what I want you guys to do is go ahead and read the steps of finding the volume using the disk method. So pause the video and do that. If you're done with that, go ahead and read this part here. And then also read the upper right-hand corner. And we're going to go ahead and get started on example 1, okay? Example 1 says find the volume of a solid formed by rotating the graph y equals square root of x around the x-axis, keyword around the x-axis, between x equals 0 and x equals 4. So then here is my graph. Now I know y equals square root of x is going to be in the form or shape of that. So I'm just going to have something that looks like this. Now I know it's between 0 and 4, so this piece right here will be 4. I know I'm going to have a rectangle right here. And as this rectangle disk is evolving around here, I'm going to have all of the disks added together. So my goal is to ultimately find the area, or I'm sorry, the volume of this piece here. But then also don't forget that as that disk is evolving around, you also have the area of the bottom piece right here, or the volume of this bottom piece right there. Okay, so then with that said, let's go ahead and match it. Which of the two equations will you be using? So here is your formula. You want to make sure you find the right one that you're going to be using. Given the fact that your radius is a vertical, you're probably going to be using this one in terms of x. So let's write that down. Volume equals pi, absolute value, integral of a to b r of x squared dx. So let's plug it in. Integral from 0 to 4, because that is your a and b. R of x is going to be the radius, okay? And remember, this piece right here is your radius, which is the height, which is y. And remember, your y is square root of x. So then if I have a square root of x, don't forget the square right here. You know the square root and the square cancels, so you just have x dx. Well, let's go ahead and integrate this thing. 1 plus 1 is a 2. Divided by the 2, I have 1 over 2x squared. Evaluate that from 0 to 4. So then I'm going to plug in your upper bound. Your upper bound is going to be 1/2. 4 times 4 is a 16. That's going to give you an 8. Minus, plug in your lower bound. Your lower bound is 0, so it's just 0. So 8 minus 0 is 8 unit cubed. Oh, I forgot something. Don't forget your pi, which is right out here. So 8 pi unit cubed. So we'll start out with easy. So far, not too difficult, but it does get more complicated. So just keep that in mind. And then also another thing I want to make sure I notate about this is with the last example, it's important to note that your radius is a vertical because you use that to determine which formula to use. Axis of revolution, which is this orange line right here, is a horizontal axis of revolution. So just make sure you guys know that. Example 2. Find the volume of the revolution by y equals 1 over 2x revolved around the y-axis between 0 and 4. Okay, since it's revolving around the y-axis, your axis of revolution is going to be up and down, so it's a vertical line. Okay, so drawing this picture right here, if I'm drawing the y equals 1 over 2x, I know that my b is at 0, my slope is 1/2. So if I start at 0, go up 1 over 2, up 1 over 2. So this is kind of my line, y equals 1 over 2x. Evolve around the y-axis, so the axis that this is going to be evolving around is this line right here. So from there, you're going to go ahead and draw a rectangle like so. And if you imagine this just going around, because as it's revolving, the axis of revolution, the axis, is going to be this green line, and it's a vertical line because with each of the disc, it is literally revolving around it. Okay, now your integral, or excuse me, your upper and lower bound is between 0 and 4. So 0 to 4, say for example, if this is 4 right here. So then your area that you're looking for is going to be like kind of like this right or triangular shape right here. Okay, and so you know you're going to be using this formula. So volume equals pi integral a to b r of y squared times dy. All right, well, let's plug it in. From 0 to 4, r of y is going to be, now you have to do a little bit of work solving for this. Because it's r of y, what it's saying is that it wants you to solve for x in terms of y. Well, this is not solve for x, so you have to solve for x. Well, let's go ahead and multiply by 2 on both sides, and you have x equals 2y. So then here, I'll have 2y squared dy. Well, that's just going to give me a 4y squared dy. So let's go ahead and integrate this then. If I integrate this, 2 plus 1 is a 3, divided by 3, so that's going to be a pi times 4 over 3 y squared. Evaluate that between 0 to 4. Okay, so let's go about doing that. So here's your upper bound. 4 squared is 16. 16 times 4, 64 over 3, minus, here's your lower bound, 0, which is just 0. So then your answer in this case is going to give you, wait a second, 16 times 4. Oh, you know what? I'm sorry. It's actually cubed. I don't know why I put a 2 there. I was like, that doesn't look right. Sorry about that. So let's go back just a second. So it's going to be 4 times 4 times 4, 64 times 4, so 256. Minus 0 is 256 over 3 pi unit cubed. That is your answer. All right, let's go on to example 3. Find the volume of the solid created by y, or f of x, equals 2 minus x squared, evolved around the line y equals 1. So it's a little bit different. Okay, so let's go and draw the grid. A negative x squared is a upside down parabola, and then you start at 2. So I'm gonna go 1, 2. There's my vertex, and then here is my parabola. Sorry, my parabola does not look perfect, so let me just go ahead and change that a little bit. And it's gonna go down this way. Here we go. Okay, evolved around that, and line equals y equals 1. So here is a line, y equals 1. And so as I'm looking at this, because it's revolving around y equals 1, y equals 1 is a horizontal axis of revolution. And basically, you're going to be revolving around here. So you're going to be creating a bunch of disks around this horizontal line. So my axis is going to be a horizontal line. So I'm going to be using this equation right here. Okay. And then if you could just imagine, if it's going to be revolving around this, then my rectangle has to be vertical. Okay. So it's going to have a vertical radius like so. And it's going to go around and around and around 1. So if you can imagine, like in terms of symmetry, from this blue, your area that you're looking for is going to be this region right here. So I already established that I'm going to be using the first equation. So volume equals pi, and it's from 1. And if I look at this, what is my upper and lower bound? Well, unlike the other two examples, this one it actually doesn't tell me that. So how do I find the bounds? Well, you need to find the intersection. Okay, so with your intersection, you have y equals 2 minus x squared. The other one is y equals 1. Well, then let's set the y's equal to each other. 2 minus x squared equals 1. Let's move everything to the right side. X squared that's going to be a minus 1. And then if I can factor this out, x plus 1, x minus 1. So x is just going to be plus 1 and negative 1. That's going to be your bound. Negative 1 to positive 1. And I'm going to have pi rx squared dx. So then I need to find the radius of this rectangle here. And the radius of this rectangle here if you look at this, it is going to be, it's going to be the top minus the bottom. And if you look at it, what is the top? It's this blue line or this blue graph. And that blue graph is symbolized by 2 minus x squared minus the bottom. What is the bottom of this? The bottom of this is going to be, because you're essentially kind of looking at this from the perspective of finding the area of this rectangle, it is going to be this red, which is 1, so minus 1. So r of x is equal to 2 minus 1 is just a 1 minus x squared. So there's your rx, or r of x. So volume equals from negative 1 to 1, pi, replacing this rx with 1 minus x squared squared dx. Now you would have to go ahead and FOIL this out. So you have 1 minus 2x squared plus x to the 4th dx. When you evaluate this, you should have x minus 2 plus 1 is a 3, 2/3 x cubed plus 4 plus 1 is a 5, 1/5 x to the 5th. Evaluate that from negative 1 to 1. All right, let's go ahead and plug in the upper bound. Your upper bound is going to be a 1, so that's just 1 minus 1 cubed is just 1 minus 2 over 3 plus 1 to the 5th power is just 1 over 5. Well, this is kind of messy right here, so I obviously want to find the common denominator, which is going to be a 15. So I can make this a 15 over 15. The 3 becomes a 15. 2 times 5 is a 10. And if the bottom 5 becomes a 15, the top becomes a 3. So then 15 minus 10 is a 5. 5 plus a 3 is an 8. 8 over 15 is your first part. Don't forget your lower bounds. And remember, it's going to be a minus, and it's going to be in brackets, lower bound. So negative 1. Negative 1 cubed is a negative 1. Negative 1 times a negative 2/3 is a positive 2/3. Negative 1 to the 5th power, which is odd, is a negative 1. Negative 1 times a positive 1 over 5 is a negative 1 over 5. So just be careful with your negatives. Now let's go ahead and find the common denominator for this, which is also 15. So if I change that 5 to a 15, that becomes a 3. If I change the 3 to a 15, the top becomes a 10. And of course, this becomes a 15 and a 15. So negative 15 plus 10 is a negative 5. Negative 5 minus 3 is a negative 8. Negative 8 times that negative here is a positive 8 over 15. Add your numerator, 16 over 15. Don't forget your pi. Unit cubed is your answer. All right, you guys, now that we have gone over 3 examples, I want you guys to go ahead and take a look at this piece of paper right here. It's not in your guided notes. I'm sorry, I actually passed this out separately. But these are some of the questions from your textbook, and there are 1, 2, 3, 4, 5, 6 different examples from your textbook, and the numbers are there. And I want you guys to go ahead and ask yourself several questions, and there are 4 questions. Like 1, which method was used to set up this problem? Remember, a lot of time you want to look for the axis of revolution whether it's a vertical one or a horizontal one. And then also you want to look at the radius. Is the radius a vertical or is it a horizontal to make that determination of which one to use? Is it advantageous to use vertical or horizontal? What strategies were used to integrate the problem, and how was the volume calculated? So make sure you guys take a look at this part just so you can get yourself acquainted with more examples when it comes to this. All right, as always, I hope you guys have a wonderful week, and I'll see you guys next time. Take care.